morning. Can you hear me?
So you can see my screen. Okay, so before proceeding and jumping to anything new, so today we can start with the functions. Right, this thing for last day we were just looking into it, and if we want to print something like that, it's gonna give me the print of numbers and something like that.
Yes.
So can we leverage this and come up with, let's say, some sort of addition, or let's say some sort of counting the list? Can we do that? Let's say there is a list. I don't know, have we used that already, or maybe not, we have not used that. So let's say there is a list. Okay, there are some random numbers. Now I need to know what is the sum of this list. So len function will tell me how many items are there, 1, 2, 3, 4, 5, 6. But I need to know the sum of it. So for that, what I should do? So the first thing is I have to just think logically. Loop is iterating one at a time. So loop is something which cannot access all the elements at one time, right? So
Okay.
loop can only access one position at a time. So when I is equal to 0, it can access the 0th element. When I is equal to 1, it can access this first element, and so on and so forth. So what if we create something, some mechanism which will take one value at a time, keep it somewhere, and then it will move to the next one and then add it with the previous one. And if we can continue this mechanism, so by the time we'll reach at the end, we will sum this with the sum of all that, which will give me the sum of the entire list. So that is something that we can do. So the first thing that we have to do is we have to create an empty list. So this is how we create an empty list, right? So
Mhm.
L2 is a list, but it has no data element in it. So we will call it as an empty list. So what we have to do is, so this iteration, let's see. So, okay. So for any writing or coding anything, so the first option would be try out the same operation with a print. If you are getting the same thing with print, that means then you can do your summation, deletion, and all of that. Yeah, so yes, I can access the elements. So print of L1 of I. So this I is changing from 0 to list. So I can access that. Now, let's say if I want to store it into somewhere. So I showed you, right? There is an append and there is an extend operation. So what we have to do, we have to do L2 dot append. That's it. Append of that particular element, 0th element. And now if I do a print of L2, let's see what it shows. It's working. This is working, right? So let's see the value of I. So this is the value of I. And we can just play around little bit in the print statement. Ith position. See, now I am able to create, uh, sorry, dot append. Okay. So it's basically taking the older one and it's creating it, putting it into the new one. So the point is I am able to access each and every one. But now my objective is to add it up. So I have created a new variable, which is sum. Sum is equal to 0. And what I can do is append of sum is equal to sum plus this element. Get rid of that. sum. See, now it is working. Or if I do it like this, print of sum, it will tell you the sum. It will, okay, let's do I position, comma, the quotation ends, comma, and then the sum. So see, now I think the picture is pretty clear. So what it's doing, so the loop is traveling through each and every data element, and what it's doing is eventually, so we can keep this simple as well. There is no need eventually to create this new list. We can get rid of it. To take a sum, this would not be needed. So yeah, so this is the sum. So first I have initialized a new variable with 0 in it. And after that, what I am trying to do is every time I am adding the latest value and I am adding it to the sum. So for the very first instance, 0, sum is equal to 0 and i's value is also 0, but L1 of I is 5. So for the very first instance, sum is equal to sum plus 5, which will become sum is equal to 5. So that's what I'm getting here. The first instance, the position is 0 and the sum is 5 because it's just adding the first element. While moving to the next one, what it's doing is just adding, taking the previous one and adding to the current one. 5 plus 6, which is 11. And so on and so forth. So this technique we would be using in moving average. So there is a concept called moving average in mathematics, which comes as part of time series analysis and those things. So that goes like that. So you take the present value, add it to the previous. So that's how we would be able to tell the sum of it. Now, the reason why I have taken out L2 is uh, L2 was creating a duplicate list out of it, which is not really the need of the R. So right now the need is to do a sum of it, right? Any questions?
No,
Okay. So that is how we can leverage loops to calculate the sum of a list. And there are multiple other options as well. So so there are multiple ways of I would say take doing these loops and all of that. Uh, so that is one thing. Input, have you been able to try that on your end?
yeah,
And was it working?
no, I just was listening. I didn't try it.
So until unless you try, you wouldn't be able to get, that desired thing if it is working or not.
Yeah.
Okay, so can we use the same logic to calculate any number until let's say how do I put it? Let's say I will user will ask me to calculate all the numbers until 10 or until like 50 or 100 or until X. So can we use the same logic to calculate that?
Hmm.
The answer is yes, we can do that. So if yeah, so the answer is yes, we can do that. So all we need is, let's say there is, yeah, okay. So as part of the whole number, so we know in mathematics, it's like all the positive numbers until a certain point. So let's say the customer has asked, to calculate all the whole numbers until a certain point, let's say 5. So what we have to do in that case, first we have to create a blank list L2 and whatever the numbers we have, like the user will give only 5, right? So what we have to do it like we have to take all those individual, you know, uh, we have to rotate through it. Like, if we put range and if we put 5, we make 0. So we can iterate through all the value. We can start from 0 and go till 5. And at each and every position, we can just add a sum to it. So first we have to initialize sum to 0 and just add a sum to it. So that's how we can calculate, we can calculate all the numbers until a certain point. So that's one thing. And okay, so loop has very interesting this thing in terms of layouts. Print of star. So this we know. So I want this star to be printed 6 times. So it's just giving me 6 printouts. But the fun part is let's multiply it with this thing, with that particular value. Okay, so if we do this, what it will do? So comma, just remember during print statement, so comma will basically separate two things. And you can input n number of arguments in it. So that's what comma does, right? Now, instead of comma, I just want this to multiply it. Let's see how it works. It's taking the shape of a pyramid. So what eventually it's doing? So I is the index, I is the counter, I starts from 0 to 5. And this one, this asterisk is basically, this is a multiplication operation which is happening inside the print statement. So whatever value we have, if we put a multiplication operation with any of the character string, it's eventually multiplying those many times, and that is the number of times it's just, giving a print here. So when the value is 0, it's nothing. If it is 1, then I'm getting 1. If it is 2, then 2, 3, 4, 5 accordingly. So see, I'm not getting 6 here because the 0th one is not coming. That is the fun. But if I do this, see, I'm getting 6 entries. 0, 1, 2, 3, 4, 5. But if I just multiply it, I'm only getting 5 entries. So that's how you can play around with this. If I put this, like, we can create probably a table, a mathematical calculation tables. So those are few of the things we can play around with, or uh, we can create multiple shapes here. Print of, what if we just put a blank here and we put a blank here as well. Okay, it's nothing happening. So yeah, so these are few of the things that we can use to come up with different shapes. So these are more or less, interview questions. In a real world, you would be hardly using these kind of things. So these are majorly important in case of in case of an interview questions and those kind of scenarios. So that's in short about this. Now, let's do one thing. Let's jump into functions because that is probably one of the important thing in Python. So I'm just, closing this, opening a new tab here. So these I had already created yesterday, and the things that we would cover here. So functions, intro and syntax, user-defined built-in function, function parameters, types of arguments, lambda function, global and local variables. So that is a global variable, and these are local variables, like that. So what are functions? So functions are something which are kind of predefined, thing, like this is the best example of a function. This is the best example of a function, print statement. Now, why print statement is a function? Because I am just calling I'm just calling this function to get an output. I'm just calling to pass a particular value so that this will appear on the output window, on the, on the outside window. I am not bothered about how it is doing that. I'm not bothered about how the inputs are getting converted into outputs. right? So I am not at all bothered about who is doing that or what is the code, who has written all of that.
Hmm.
So if I do like this, okay, if star a single star. I'm not getting this point. I'll show you later. So yeah, so the point is, so this is one of the good examples of function. So long story short, function is something which will or will not take anything as an input, but it will give you something as output without we bothering about how it is doing. So that is all about function. So until now, we have seen couple of functions like length we have seen append, we have seen extend, then for any operation like let's say x is equal to 5. So this is a variable. So if we do the usual technique x dot tab, what are the things we can do? So as integer ratio, this is a function. These are not functions. So best would be to create a list, a quick small list. Yeah, let's start with these three. So this is a list. So L1 dot tab. So this will show you the number of functions we have here as part of Python. And we don't have to define it. We don't have to do anything with it. We just have to call it. So these are the different functions that we have. So you can just pop, remove, reverse, sort. It's pretty self-explanatory. It will tell you, you know, what exactly this function is doing. Now, function usually has two things. Uh, once the first thing is function body. So I'm not going very details into it, but just you know, it's just these are good to know facts. So function has something which is body where the main code would be written, you know, where you will have your main code where actually the code will be written here. So it will be stored as part of the Python package where, you know, these things are actually installed. So if you go to C drive and all of that, so there you will actually find the Python, you know, the function details or what are the codes written to actually be able to create this particular function. But that's something that we shouldn't really bother about because those things are crucial for, you know, people who would consume Python as IT, as like, you know, as part of their development work. But we would be consuming Python as part of data science, as part of a data scientist, you know, to analyze data, to derive something out of it. So that's why we would not be needing those much of information. We don't need to go there, literally. But yeah, so function has, there is a body which has the, you know, the main written codes in Python, which has lot of, you know, something written. Hash include what to do, what not to do, all the logic, pseudocodes, everything is written there. And once that function is written somewhere, we call it defining the function. So that function must have been defined somewhere. But while using in our day in day out operation, what we will do, we will just call the function by the function name, by the name of it. Now, a particular function might have a, you know, might have a this thing, might take argument as part of it, might not take argument. That's a second discussion. But that's how we will be using a function. So for our case, this is the part that we would be bothered about. So we will just, you know, consuming it. So we will just call the function. That's it. We will just call it by its name. Now, how can we create a function then? So that's okay. Now that's what a function is. Now, as part of our data science process, we might need to create some functions on our own, right? So first thing is what exactly this is doing. So take the example of print. So print has been written in such a way that whatever you write or whatever you send as part of the argument, it will just give you that same output without changing any materialistic value inside of it. But yeah, we can probably play around with the font, with the, those things, font layout and those things, but it will retain the same thing. That's what the print function is all about. The length function is meant to count the number of elements present inside a list, or a tuple or something like that, or a string. So that's what length is meant to do. You following it, Ranjit?
Yeah, but I'm getting syntax invalid syntax error.
Where exactly?
In L1457 I have mentioned. So I
Hmm.
have the define function body, but I'm getting the invalid syntax.
No, no, no. The define function, see, the define function body, this is just, I have written to let you understand this thing. See, this is a markdown. This is not a code.
Acha,
If
okay.
I make it code, if I run, I will also get that error.
Acha, okay, okay. The same only. Yeah.
Yeah, I will also get that. This is markdown. This is just, just to help you understand how this thing is.